released. It's not like you get few light and there's a lot. I mean, it's not like you get a few x-rays and it releases a lot. So if it's proportional, basically. Number 2, the light exposes the photocathode, which emits electrons in proportion to the light. So do you see a pattern here?
Yeah.
So x-rays interact with the input phosphor. Phosphor is going to release the same proportion of x-rays that it absorbed. Are you good so far?
Yes.
Okay. And the light that is absorbed by the photocathode is going to emit the same amount of electrons. So everything is happening in proportion. X-rays proportion to the light, and this proportion to the electrons that's being released.
Okay.
We good so far?
Yes.
John, you good?
So it doesn't lose any energy at any point?
Don't think about energy, just think proportion.
Okay.
Number 3 is very important. The ratio of light to electron emission is not 1:1. So that means it takes many light photons to result in the emission of 1 electron. So part of the reason why this photocathode at input phosphor is so wide is that we need a lot of light photons just to be able to create 1 electron. Okay? Number 5, electrons are focused toward output phosphor by the electrostatic lenses. We already know that. Number 6, we already know that. Number 7, each electron that we produced where? Where was the electrons first produced?
Photocathode.
Photocathode. Each electron that we produce here results in more light photons that was necessary to cause its release. Do you get what that's saying? Yes, Cody.
So is that why number 3, the ratio is not 1:1?
Mm-hmm.
So there's gonna be more. So there's gonna be more light.
So we
I'm
need a
confused.
lot of light photons
Yeah.
in order to create 1 electron. However, once we have the electrons created,
Yes.
1 electron is going to be able to give us a lot of light photons. That's basically what number 3 means.
Okay. I think I'm just confused. Like I understand all that you just explained,
Mm-hmm.
but when you compare that to number 2, and it's saying that the electrons are also proportional to the light.
The light exposes the photocathode, which emits electrons in proportion to the light. Yeah, that is kind of confusing. Okay, let me get back to you on what that means.
Okay.
But for now, just understand that in order for us to get 1 electron, we need a lot of light to be created first.
Mm-hmm.
But then once we get electrons, we can easily create light again.
Okay.
You said once we get the light.
So here at the photocathode, what happens?
The photocathode. It mixed with the light converts to electrons,
Okay.
something like that.
So what I'm saying is, in order for us to be able to create just 1 electron at the photocathode, we need a lot of light.
Okay.
That's why the input phosphor is very, very wide, in order for us to be able to absorb all of that X-ray and create a lot of light. Because we need a lot of light just to create 1 electron. Okay? However, when we already have the electrons that we need, it's easier to convert it back to light. Because each electron that we have, it's going to give us a lot of light. So a lot of light needed to create 1 electron, however, only 1 electron needed to create a substantially good amount of light.
I think I
That's what that means.
understand it
Number
now.
2 now.
Yeah, I think that like 1 and 2 are only referring to the input phosphor
The
and
steps that happened
photocathode.
before.
Yeah, and then the rest of it is referring to the anode portion.
Correct.
Okay, I understand now.
Yeah.
So
where the electron turns into that light photons, that's at that output phosphor?
Yes.
And this is all the tube right now.
This is the image intensifier tube, which is on top of the fluoro machine. So this whole thing that we're talking about is the image intensifier tube. Melanie, did you understand what I said? You don't have to be scared, I was just asking. Okay, yes.
I just wanna clarify, so the X-rays are going to the input phosphor, they're turning into electrons.
No.
A electron,
Input phosphor, it's light,
It's
remember?
the light
I mean,
that's
turning into
converted.
light.
Mhm.
But I mean, yeah, and then the light goes to the photocathode, turns into an electron,
Mhm.
then it's accelerated at the anode, well, it's, focused by the electrostatic
Lenses.
lenses, and then it's accelerated at the anode, and then that electron turns into many light photons.
Correct.
Miss
Okay.
Bonilla.
Yes.
Those electrons.
Shaheen.
different
Shaheen,
levels.
yes.
Miss Bonilla, so it's like starts with X-rays. The X-rays hitting the input phosphor
Mhm. The X-rays are coming from where?
from the tube, not from the target, from the.
After the tube, what's after the tube? Patient,
Oh, I see. This is after the patient.
yes,
This is from the remnant beam.
yes.
Oh.
Remember I told you the X-ray tube is underneath the table, goes through the patient, and then we have the image intensifier on top of the patient. So just imagine what a fluoro case looks like in your head, right? Who else had a question?
Charles.
So the purpose of the image intensifier is to give you a brighter, better picture, right?
Yes.
So that's why the proportion of X-rays equals the proportion of light emitted, right? So if you have a lot of X-rays, you're gonna have a lot of light.
Mm-hmm.
And then once it goes through the process of going into the input phosphor, turn to light, then into the photocathode to electrons, then I hate to go through the whole thing, but as it's focused towards the focal point,
Mm-hmm.
then eventually reaches the output phosphor. Is that why the light is bright?
Correct.
That's what I'm trying to get at.
Correct, so let's pretend that the light that we had here was 25, okay?
Yeah.
So the 25 light that we had, let's say, gave us 10 electrons.
Right.
So these 10 electrons are flying towards the output phosphor. Remember, electrons can give you a lot of light. So let's say this 10 electrons, each of these electrons give you 100. So
Right.
what's 10 times 100?
1,000.
So we ended up with a lot more brightness up there, right?
Right.
That's the whole point.
Yeah. That's why
So-
I was trying to, get that, to connect the dots.
Yes.
So that makes sense.
So the purpose of the image intensifier is to intensify the image and make it brighter. Because remember, before we had the image intensifier, what was our issue with fluoro?
The images were too dark.
Images were too dark, we couldn't see.
Yeah.
So this was our solution to get a brighter image. Lee, you look confused.
I'm just trying to go over it.
Okay. All right.
So, man,
Yes.
but can you, just to make sure, can you check and make sure like number 2, like, makes sense?
Yeah. I'll go back and check number 1 and 2, and then just ask me next class to clarify.
Okay, thank you.
Then before you go on, you said something, 1 and 2 happened where, and then the rest of them happened where?
What? That doesn't make any sense.
Y'all have to see start, it's just
It
input
starts from the
phosphor,
bottom to the
right?
top.
Mhm.
Okay,
That's all.
then it goes to the photocathode, and then those electrons go through the electrostatic lens,
Mhm.
right? And then they go through the anode to the output.
Yes.
Okay. And that creates,
But you also need to understand what is happening. So we have X-rays, which are converted to light at the input phosphor.
Can you see the X-ray?
X-rays to light, light to electrons, electrons back to light, at the output phosphor.
This is for me.
No, probably helps other people too.
Oh, okay, well, I don't know. Electrons, light, and then.
Light
Like
back to,
different
wait, X-rays to light to electrons,
And then
electrons to light, okay, good. That's it? Mm-hmm.
So I have X-rays and amplification,
Is it focus?
input phosphor. It's made of cesium phosphor.
Mm.
And then the light interacts with the cathode and it converts it to electrons.
Mm-hmm.
Then the electrons are focused by the
Electrostatic lenses,
which are negative.
which are negative.
Okay. And the electrons focus towards the accelerating number,
Mm-hmm. And what was the constant potential for
25.
25?
And then electrons go to alpha phosphor and are converted to,
Correct.
and that's it?
That's it for now.
Okay.
You-
Okay,
it's-
okay, I got that.
What you have is right.
What I have is right?
Yes.
What do you mean?
Like the one, like, I was confused because I didn't understand how it could not be the same one-to-one,
Mm-hmm.
but even if the process, like, it says takes many light photons for one electron,
Mm-hmm.
even if that's the same process, that doesn't mean it can't be coming out as proportional, even if it's a different process of like making the electron, it could still come out with the same number, I guess, is what
Yeah,
it's trying to
with
say.
a higher intensity of brightness.
I guess that's
Yeah.
what it's saying. I mean,
Yeah, I would
Yeah, I
have
was
to
looking at it
consult
today.
the
Yeah.
resident expert.
yeah, like it's making more sense to me, but I'm not like 100% positive.
What's the last one?
Yeah, I was looking at it and like, that makes sense. It can come out, it can go
This
in
happened
and
to
come out
The
the same, but
accelerating
just-
anode
yeah.
has a
Probably
constant
not.
potential of
Right.
25
Yeah.
kilovolts.
So this is a.
Yeah. Like the alpha phosphate.
All right, moving on,
That's
Just saying, like,
right there.
because we really have to move on.
Right this way.
So we're gonna go over some terms and definitions. And some math problems. They're not that bad.
Are you sure?
Yes. So for fluoro, we have, I think, 4 terms that we have to know. The first one is brightness gain. What does that sound like? Brightness gain.
Getting bright.
Gaining of brightness, right? So basically, it's expressing the ability of our image intensifier tube to convert X-rays to light, and in that process, increase the brightness. That's all it is. So brightness gain is strictly talking about the gain in brightness that we get at the output phosphor compared to what we started with at the input phosphor, okay? Now, flux gain is talking about the increase in light intensity. So brightness gain, we're talking about the gaining of brightness. Flux gain is talking about the increase in light intensity at the output phosphor compared to what we had in the input phosphor. Yes?
Brightness and intensity is not the same.
No, it's not the same. Because, earlier I said, in order for us to create one electron, we need a lot of light, correct? But we only need one electron to create a lot of light. So that's why we have an intensity, an increase in intensity at the output phosphor compared to the input phosphor. So the intensity of light is increased at the output phosphor. That's basically what flux gain is. And it can be expressed as the ratio of the number of light photons at the output phosphor compared to the light photons in the input phosphor. Because we started off with, I think it was 25 that I said, and then we ended up with 1,000. So basically, flux gain is talking about the increase in the intensity. So is everyone good with these 2 terms? All right, Reagan. Brightness gain. What do you think that means?
Is it just saying it's an increase in brightness, like due to the image intensifier converting the X-ray? I don't understand. And then what's the?
Yeah, you had a dose of.
that was
You just
it.
said that was it. It's an increase in brightness due to the X-rays that are coming in, turning into light.
Okay, and then so flux gain is just talking about the intensity of that?
Mm-hmm.
Okay.
So brightness gain is only talking about the increase in the image brightness that we get at the output phosphor. Cause at the input phosphor, we start off with not so great. By the time we get to the output phosphor, we have gained a lot of brightness, which is what we want. Flux gain is just talking about the intensity, or I guess another word can be like amount, but I wouldn't use it. So, flux gain is basically talking about the increase in the intensity that we get at the output phosphor compared to how we started off at the input phosphor. Mhm. Because once X-rays are exiting the patient and they interact with the IP or the input phosphor, our image is not bright yet, correct?
Yeah.
So this process needs to happen.
And it's talking about the intensity of light.
The intensity of light, yes,
No.
yes.
The brightness gain is at the first phosphor layer and the flux gain is at the top phosphor.
No. What does that say?
Brightness gain is an expression of the ability of an image intensifier to convert X-ray energy into light energy. That's the first level, right? The first one we saw.
No, it's being converted to light at the output phosphor also.
So it's talking about the tube in its entirety.
So brightness gain is strictly increasing the brightness of the image. Flux gain is talking about the increase in intensity of the light.
Correct.
It's just terms that you have to memorize. Okay?
So brightness?
Look what it says. Flux gain, ratio of the number of light photons at the output phosphor compared to the light photons in the input phosphor. Earlier I used hypothetical numbers. We had 25 light photons at the input phosphor, but we ended up with 1,000. So flux gain is basically talking about that
Like the ratio?
that
number.
increase that we got.
Oh, okay.
Now, 1,000 to 25.
So the
25
increase.
to 1,000. Brightness gain is strictly just talking about the increase in brightness that we achieve
Mm-hmm.
going from input phosphor to output phosphor.
Oh my god, this still sounds like the same thing.
So if you ask a question on the test, flux gain is just gonna be, output phosphor and input phosphor, right? The difference or something like that, that's just how it's gonna be increased. The ratio, yeah, basically.
Yeah, increase in light intensity. And then ratio of light photons at the output phosphor to the number of light photons in the input phosphor. Brightness gain, increase in brightness of the image.
Basically.
That's it.
Okay.
Okay.
Three questions.
Brightness gain, increase in brightness of the image. Flux gain, increase in light
The light
intensity.
intensity.
Or the ratio of light photons. That's it, don't try to make it complicated.
That'd be method.
They could have just made this one word. It's
Aye.
Alright, so we have some more fun definitions.
That's the comparison, basically.
It's not
So much
good enough. They
So
can minimize or
minification
small
gain,
enough.
what does the word minimize mean?
Make it
To make it
smaller.
smaller. So what happens is, the latent image, because our output phosphor is a lot smaller than our input phosphor, what do you think happens to our image?
It gets
The image
smaller.
size gets smaller. So minification gain is talking about the reduction in size of the image compared with the image that we get at the input phosphor.
And that makes the image appear brighter because the image size is smaller and that's a lot more light on it.
Focus on that one spot, yes. Yes,
Where do we see the input phosphor image?
it's a latent image, so we don't actually view it.
The latent image is bigger than this, the final image such as this. So that we,
Read what it says carefully.
Uh-huh.
So that means.
until the input phosphor is widely compared to the amount of the output phosphor. with a reduction in size that occurs as the output phosphor electrons being concentrated in a smaller diameter create a small image, but with increased brightness. Makes sense. But what happens to the first? What happens to the first image that was created?
That one was very large.
And that was the latent image, right?
That's also a latent image. But by the time we do all that process and get it to the
Final
output
image becomes
phosphor,
smaller and
yes,
more
the size becomes smaller.
smaller and more focused.
So we get a smaller image, but it's a lot brighter.
There's a more focus in the
Makes sense. Yeah, yeah.
All right. If anybody's lost, let me know now.
So in order to get the brightness gain, you multiply flux gain. So already.
Don't go there yet. I'm just asking you, do you understand brightness gain, flux gain, and minification gain?
Okay, sorry, I thought you were about to go to the next time. I was like, wait, hold on.
How about we go back to the slide and start from the beginning?
We're gonna be stuck on chapter 15 forever. Carla, you're very quiet. You good?
It's been a rough day.
Samantha, you good?
I am good. I'm gonna have to kind of review it, but it's, you know, kind of.
Okay, brightness gain, in a nutshell.
Brightness gain is
Increase
the
in
increase
brightness
in
of
brightness
the
of the
image.
image.
Period. That's it.
Flux gain.
Increase in the light intensity,
Yes.
period,
Hold on, hold on,
or a
hold on,
ratio
hold on. Flux,
of light.
Wait, you don't have the slide?
I do, but I have to
adding
like
notes
keep
to
it.
just
Oh.
typing stuff that I understand because
I don't understand all those words, just tell me what I need to know about that one word. Flux gain?
Flux gain, increase in the light intensity at the OP, or output phosphor. Lord, just help me.
So basically it's just saying like when the x-rays are converted to light, the number of photons, cause that's intensity, number of
Mhm.
photons, it's, less at the input phosphor and then
it's
it
a
gets
lot more at the output
more at the output phosphor. So it's just
Mhm.
saying the number of light photons, that's all it's saying, within the intensifier. That's all it's saying.
That's all it's saying.
The
Increases
number
the
of
number
light
of
photons
photons.
is more in the output phosphor than in the input phosphor.
Yeah, you can.
Yep.
flux gain is gonna have a number about like an actual number, and brightness gain is not, right? It's just saying
The brightness.
the brightness.
For the terms, no numbers, but you may get numbers once you start doing formula.
Okay.
And brightness gain is after the flux gain. You see on the image.
Correct.
Okay.
Yes, so flux gain is basically talking about how we went from a small amount of light photons at the IP, and we end up with a lot at the OP.
So it's the ratio of
Yes.
electrons.
And then what about, minification gain?
The reduction is.
Basically, how we get a smaller image at the OP compared to what we started off with in the IP.
There's a problem with that too?
I think so, yes. Alright, so moving on.
Yes.
Traditionally, the formula for brightness gain was flux gain times minification gain. That's traditional, okay? Now, it's expressed as the conversion factor. You're not going to have to remember the conversion factor formula, cause I feel like it's complicated, but this is just an FYI, how it's expressed. Candela per square meter per millirangin per second.
Now
So
you're going to-
candela, square meter, M squared, millirangin per second.
That's just too much.
It's square meter or meter square?
Square meter and meter square, same thing.
The potato.
Potato, potato. Yes, Jay.
Does that mean that candela and millirankins can be multiplied together while meters squared can be multiplied by seconds?
Oh, no. We're not worrying about that. Just know how it's expressed.
Okay.
We're gonna get into that in a second. Alright. Let me show you the formulas real quick. So brightness gain, you can find it by multiplying your magnification times your flux. Flux gain, you can find it by taking your output light photons and dividing by the input X-ray photons. Okay, yes.
So they'll give us the numbers like if they want to.
Yes. And then if you need to find your magnification gain, you would take your DI, which is your diameter of your input phosphor, like how wide it is, and then divide it by your DO, which is your diameter of the output phosphor. And the conversion factor, you just have to know this, but I'm not gonna ask you this on the test.
Say it again about the conversion. Just know how it look. Is that
Just
what
know the, like how you write it out.
you? Okay.
So CD.
But you do have to know brightness gain, flux gain, and magnification gain.
And you said the D stands for the diameter.
We'll work some problems to see how it fits. Okay,
What's up?
okay?
Yeah, I'm fine.
All right, can we move on? I sent you the PowerPoint, you should have this.
My computer is different.
All right, so example, you have a question like this. What is the brightness gain for a 17 centimeter image intensified tube
So flux gain.
with the flux gain of 120, hold on, flux gain of 120 and 2.5 centimeter output phosphor? First thing, what is it asking you to find? Brightness gain. And we know that the formula for brightness gain is flux gain times magnification gain. Now, in the question, what else does it give you?
Diameters.
Okay, and what else? Flux gain, okay. So it gives us flux gain, which is 120, but do we have the magnification gain?
No.
We do not, so what do we have to do?
Find it.
Okay, and how do we find the magnification gain?
Diameter of the square. DI would be square.
So what would be our DI with this problem? Which one of the numbers?
17.5 centimeter.
17 would be our DI, which is our diameter of the input phosphor. And then what about our DO? 2.5, because
Yeah.
it says that's the output phosphor. So we would do 17 over 2.5 squared, right? Which would give us
Let me try.
the answer. Somebody do 17 divided by 2.5 squared.
Thank you.
Oh, I have it right there.
46.
36.
But I was never going to come first. 17.
You alright, I'm alright.
Times.
So,
So you have 46, right?
mhm.
Yeah, that's the answer.
You want me to explain it again?
Nope.
I can.
Maybe we're done. Or, do you have more questions?
No, I just have that one question.
You know it on the board. Can you give us
So all we
I
found
was gonna give y'all
was, we
worksheets
found the
next class.
magnification gain, which is 46, right?
So let's
And
go
then
back.
we're gonna multiply it times the flux gain, correct?
Correct.
But I can't see what that is. What is it? Okay.
Does anyone need me to explain this again?
See, yes.
You do, okay.
Probably on the board.
I hate freaking spreads. I'm ready.
The word.
The word?
Like a word.
No, I'll do it on the board. Yeah. You do it on there.
So it was 46.24, but I'm guessing you rounded down to 46.
Okay. This is gonna be up close and personal. So, Jamaica, what is it asking you for?
This is what is the brightness gain for a
Okay.
17 centimeter image intensifier tube?
Okay.
So with the flex gain of 120 and the 2.5 centimeter output.
So it's asking you to find the brightness gain, correct?
Uh-huh.
And what is a formula to find brightness gain?
Brightness gain equals magnification gain times flex.
Mm-hmm.
Is that right?
Flux gain times minification gain. Are we good so far?
Mm-hmm.
Alright, so we need to find brightness gain. Do we know any of these numbers?
The flex gain is 120.
Okay. Do we know the minification gain?
I don't know it, so I don't know which number that would be. That's why I'm confused.
It doesn't tell you what the
Right.
minification gain
So
is,
it's,
right?
it's a question mark.
So that's also a question mark. So we
Okay.
need to find what now?
The MG.
Minification gain.
Mm-hmm.
And what is the formula for minification gain?
D1 divided by, what is D0? Is that 0 or O
D
squared?
So DI divided
Can I say
by,
something before you finish that?
yes,
So DI stands for image intensified tube, and DO stands for output phosphor?
no.
Okay,
DI
so-
stands for
Phosphor?
diameter of the input phosphor.
Okay,
DO stands for diameter of the output phosphor.
that's right.
So in the question, if it says image
there it
intensified
says-
tube,
Yeah.
you can assume they're talking about the input phosphor.
Thank you. That's what I was trying to make clear.
Mm-hmm.
Yeah,
All right.
'cause that's what I had asked you on the other slide with the DI and stuff.
Oh, I'm sorry.
Because I didn't know what it said.
So now that
Basically,
we know what it
how
stands
wide
for,
our input phosphor is.
Okay.
Okay. So we have our formula for minification gain.
Mm-hmm.
Now, what is our DI?
$17.
Okay. And our DO?
2.5.
2.5 squared. So 17 divided by 2.5 squared would give us 46.
Okay.
So now that we have 46, which is our mg, we can plug it in, right? So what would we multiply the 46 with?
120.
Flux gain of
120.
120. So flux gain times minification gain. That would give us our answer, which was, I forgot the answer,
5,520.
5,520. That is our brightness gain. Does that make sense?
So the image intensified tube is your input. That's what that means. Thank you.
Should we, stop there for now? Or keep going? Okay, I think we can stop there for today.
The D, like the D specifically stands for diameter. Like that is what the D is.
Okay, yeah.
And then the I is
It's an
input.
input.
Yes, just try to understand the term
Yeah,
and what it
because I didn't,
means.
that's what I was,
The
I
D
asked her,
is
because
like,
I was like,
if you were to write it out, it would say diameter input, diameter output. I just wrote it
shorter. All right, thank you.
Thank you for going to the
Which is why I
PowerPoint,
was
ma'am.
trying to get
You're
her to say so that
welcome.
we can know what DI
Yeah, because I heard it, because I asked her what it was, and she said it, and she was like, we're gonna go over that, you know, later, and I was like,
is when I read it.
10th. So we have 2 more lectures. Why do you look scared?
Miss, Bonilla, did I write that right? What I put on the board, the XLEL, like try to remember it, or like X-rays,
X-rays to light, light to electrons, electrons to light, yes.
and then light back to electric signal, or?
We'll talk about what happens afterwards.
But in the beginning, the XLE, I have that right, how you said it. But is the L the